6G is evolving from simple throughput gains to fully AI-native operation, embedding intelligence across the RAN, edge, and core. But this shift faces a massive hurdle. How do you learn effectively with limited labels, heterogeneous data, and non-stationary propagation? The answer lies in the Joint-Embedding Predictive Architecture, or JEPA. Unlike reconstruction-based methods like masked autoencoders that waste capacity recovering raw noise, or contrastive learning that struggles with wireless preserving augmentations, JEPA operates in latent space. It learns predictive representations by predicting missing or future embeddings from available context. The architecture relies on three components: an online encoder, a predictor, and a target encoder. The target encoder is updated via exponential moving average of the online parameters, providing slowly evolving, stable targets with a stop gradient to prevent collapse. The predictor then maps context embeddings to match these latent targets, forcing the model to capture abstract, decision-relevant radio structure rather than hardware artifacts. For 6G, we map heterogeneous observations into a unified token sequence. Modality-specific tokenizers project CSI tiles, beam domain sweeps, KPIs, and topology graphs into a shared embedding dimension, aligned via structural encodings. Wireless-aware masking strategies, burst, spatial, and future masking, train the encoder to handle partial observability and asynchronous data streams. Crucially, target design dictates performance. In a beam management case study, we introduced an auxiliary future beam energy target during pretraining. This beam-aware future JEPA significantly outperformed generic JEPA, MAE, and supervised baselines in label efficiency and out-of-distribution robustness, particularly under low SNR and high-mobility stress tests. JEPA acts as a shared predictive representation layer for ORAN xApps and core analytics. However, deploying this requires solving multi-timescale prediction, action-conditioned world modeling, and federated training constraints. Predictive representations are the foundation of AI-native 6G. For more deep dives into wireless AI research, explore the links below.